Welcome to another long overdue video. This time we're looking at the Dark Easel. This is Makenoise's combination of all three standalone modules. There's the no control or zero control. I prefer no control because it sounds funny. No coast and Strega. Now together people have called this the Dark Easel because it sort of has the same sort of flavour as maybe a Buchla command, or the Buchla easel. It can make some just way out there sounds, but this thing actually proves that the total is in fact much better than the sum of its parts. You could argue that each one of these modules or devices by themselves isn't necessarily the best in the world, something to write home about, but together they complement each other. It just works really, really well. So you may ask, why did I get this? The main reason is, and it's a strange one, I actually really love the Vulcan Modular. But it has one big problem, and that is there's signal bleed. Because of the way the Vulcan Modular uses those little wires when you plug it in, there's no actual disconnection of the signal. And if you're starting to do things and recording it and capturing the sound, you can hear signal bleeding in, like the default routing bleeding in, and it's just there's some problems. So basically, I actually really liked that sound. I would have loved to have got a command easel, Buchla. I couldn't afford one, so I was looking what can I do, and along came the Makenoise. I was going to be, I would have put a video out a long time ago when I got the no coast, but just when I was about to, ready to do it, I'd worked out how to use it, I decided to get the no control, and I thought, when I know how to use it, I'll put a video out. And of course, same thing happened. I said, well, I'll get the Strega, and I'll put a video out when I sort of know how to use it. And today, in fact, is that day, so hopefully I know how to use it. So I can show you a little bit about this. Basically, it's a similar sort of feeling to an easel. It's got a touch capacitive sequencer and command input. It's got the single voice, more West Coast based, wave folding and shaping than East Coast. It's got it's got low pass gate, wave shaping and folding. But it does have a 4-stage envelope. It doesn't have true ADSR because the decay and release are both controlled by the same decay knob, but it still is an ADSR style envelope. And then of course the Strega, which it's difficult to put into a category. I think Strega is all on its own. It is. It's a very strange beast. If you tame it, it can make the most beautiful sounds, or it can just sound like ripping metal. It's a crazy device. When you put the three together, there's basically nothing you can't do. So anyway, that's my reasoning for doing it. I'll very quickly take you through each of the devices, what they can do, and then maybe what we'll do is do something a bit interesting. Everybody knows the Krell patch. It's a simple patch, and I can show you the Strega version. So if you've seen Makenoise's videos, they actually do a Krell patch on the no coast, which is a pretty good version, but it has a few limitations because there's only one source of randomness, so that high pitch notes are quick and low pitches are slow and all that sort of stuff. So anyway, without further ado, let's go. No control. So this thing, at first you look at it and say, why would anyone do that? We can get digital sequences that have thousands of steps, or multiple banks of 64. This thing's got 8. The main thing about this is completely analog. So each one of these pots is completely, there's no quantizing. It's whatever value you want. You can have 3 values per stored note or per stored position. That can be either played as a sequence. So if I can start the sequence, you'll see it goes up, tempo to start, or you can play it manually. Now the other thing you can do is you can turn off. See, when I press the button it goes to a different step. You can turn that off so that it doesn't nothing happens in terms of changing a step. But if you look carefully, there's a light up there. When I put my finger down, you can see that it tells the pressure that I'm pressing. So it's another performance piece, so you can have a sequence going and use the touchpad to actually change it. So anyway, so what does the no-coast do? Well, again, it's a sequencer. It goes through the sequence, and every time the sequence changes, I'll put that back on, this is the 3 sets of values that is given. 1, 2, 3. The outline represents the same outline as the controls. Now, these two have special meaning. You can, of course, ignore that meaning, but when you're doing a sequence, this one controls the strength of the note, this one controls the time of the note. So let's show you what I mean. If we put all of these to the left, and we can start the sequence. Let's just do it slowly. Now, this is the tempo control knob. So what I can do is I want every second one. Yeah, put it all the way up here. So that's controlling the time. Now you can see it's exactly the same. If I make the sensitivity better, I have to make it faster because otherwise you're not going to see it. See how now you can see it's going ba-boom, 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 ba-boom. Short, long, short, long. And obviously you can tune this to however you want. So yes, it's 8 steps in the sequence. However, things like rests, you don't need to have a rest because all you do is you just change the spacing. So you can easily have a 16-beat sequence if you're doing things like having rests and multiples in the sequence. So anyway, that's it. If you turn it all the way to the left, it ignores the differences. So as you can see, everything's going at the same speed. It doesn't matter how I turn these. And what that does mean is that I can use that as a voltage output. Now, if we slow this down, the middle row is the strength. Now, these are the sequencer output gates. These are the playing it directly output gates. So if you have a look, see that there's nothing happening. If I turn this all the way up, what happens is you can see the strength. This is actually an envelope. So it's a pluck style envelope, so it has instant attack and it decays. You can actually see by the graphic it gives you. And what you can do is if I turn the knobs to halfway, I'll just do them all, you can actually see how now it gets up there quickly and it fades away very quickly. So you can control the envelope so that the further round you twist it, it actually has a sustained phase, and you keep twisting it back until you don't have any more. In fact, it's probably easier to listen to this. There's not that much more to explain here. You have a direction button, and let's make it go fast so you can see. Change the direction. Well, yeah, that's good. You have, and you can see the arrow at the top. It tells you which direction. You can stop a sequence. You can reset. Now, each one of these is a gate that is brought up, or it's triggered when that step gets triggered. So, for example, if I was to put a wire in that step and put it to reset, so you can see it's just going this step, then this step, and it gets to here and it immediately resets. Now, of course, I can put it to somewhere different. So it always remembers the one you press as the reset. So if I press this one here, when you reset, it goes back to that. So you can actually control, even with a simple sequence, you can control different parts of the melody. So I'll stop that. Anyway, let's just check. So we'll sort of move on to the no coast, and we can actually demonstrate some of the no control. So, okay, no coast. It does have a MIDI section. You can plug MIDI in, where it says MIDI in, surprisingly, and you can get CV and gate and all that sort of stuff out, as usual. But you can also run this purely voltage, 1 volt per octave. So we have a math section here. So ignore this just for now. I will get to a special use for those in a sec. This section here has a clock or a tempo that you can tap. So if you have a look at that orange light, you can see I can actually set a tempo by tapping. That sets the clock. You can also specify the tempo internally. That is a random voltage. It gets clocked by the clock, so it's basically a built-in sample and hold. And this is a math section. So you have two versions of the output, which is this voltage plus this one multiplied by this attenuverter. Now, when you don't plug anything in, it gives you effectively a maximum voltage. So I can turn it, and interesting thing, that LED tells you the state of the voltage. So as I turn it, so it goes green. If I go the up way, it goes red, negative, positive. So you can use that. For example, if we were to do something, and again, I'm jumping a little bit ahead, but this is the dynamics, the low pass gate output. So what I'm going to do is I'm actually just going to turn that up, but of course I'll have to do this. Plug in the headphones. I'll just make sure it's not too loud so I can. So you're basically just controlling the output of the low pass gate. Okay, nice and simple, but we'll do that just so we can hear some things to start with. So we have an oscillator. Oh, and by the way, you are hearing exactly what I hear. This is my wonderfully expensive and high quality $15 active USB speakers running off a power bank. The power bank's also powering the light for this video, but you're hearing what I hear. This is the output from the cheapest possible speakers you can get. So just to give you an idea. The oscillator, pretty obvious. Coarse pitch, fine pitch. We have a linear frequency modulation and 1 volt per octave. It outputs a triangle wave, and a square wave. And those are, it's a semi-modular, so they're routed through to various parts of the synth. This is very close to modular, but there are one or two things that you can't get access to except through the built-in routing. So one of them is, for example, the wave shaper. You don't have an output of the wave shaper. It always goes in to this mixer control. So you could argue you can do it, but yeah. Anyway, so now let's do something. We said that we have a gate. Now, sequencer, playing manually. So if I put that, I'm just going to put it on straight into the dynamics. Okay. Purely, that's just, purely an on-off, not very exciting. So there's no option for the filter to close and everything like that. So we'll leave it like that for just a moment. I can now plug in 1 volt per octave. That brownie type one is the top. So we can tune it. Now that's the interesting scale. I just did that by ear, but you can do, or there's a few interesting things. It's a bit more interesting than a standard major scale, but more than playable. Obviously, with the gate on and off, there's a few issues. What we can do is, this is the ADSR. So instead of going straight to the dynamics, I'm going to go into the gate of the ADSR. That's probably a little bit too long, so we're going to make that a bit quicker. Alright, so what have we got here? All we've done is really put a gate in and put the voltage, and we've already got a voice. So we have a mixer. If you follow the gold lines, this mixer takes by default the triangle wave, and it mixes in the wave folder. We'll get to that in a sec. That gets passed to the low pass gate, and people have said, the no coast's no good, doesn't have a filter. Yes, it does. It has a low pass gate. That does mean the filter closes at the same time as the VCA, so yeah, you probably don't get these beautiful filter sweeps. You can do it with a bit of trickiness. You can change the amplitude of the wave coming in independently. But yeah, for now, you do actually get filtering. But if you put the dial to the line, that's the point at which the voltage and the filter both go down at the same time. If you put it all the way to the top, the voltage amplifier is already at maximum, so what you're doing is you're getting a little bit of filtering to that line. So it's easiest to tell. We can break the default, so instead of using the triangle wave, we use the square. Just see, a bit loud. So beautiful square wave. Now that's maximum, so basically that's filter wide open, VCA wide open. But if you listen, so not huge, not like a proper filter sweep in a, you know, like an ARP 2600, but you still get to control that final sound quality. So a bit filtered, all out. So immediately we already have what sounds, you know, a bit like a clarinety type thing, because we've got our filtered square wave. Now this mixer takes in the wave shaper. This is where all the interesting stuff happens. So if I go all the way over here, we're just taking from the wave shaper, which it says, I mean, overtones is strange. It tries to switch between odd and even harmonics, and the multiply is really a pretty conventional wave shaper where the wave hits the top and bounces back. So let's listen. So if I take a triangle, I'm going to have to turn that up because you probably can't hear that. I mean, you'll hear it in a sec, but if I turn this up, I wave shape it. So that's the level of sound of a wave, of the wave shaper. Now it's actually fed from what we call the overtone section. Now what the overtone does is it takes, it basically goes into slightly from a slightly rounded square back to a triangle to a pulse. So if you listen, okay, so that's subtle, and I should really put the oscilloscope up to show you, but that's for another time. So what you can do, for example, let's just, there's our fully wave shaped, but we feed the wave shape so we can actually feed the wave shaper. The more harmonics you give it, the wave shaper, you know, puts it in spades. The fewer harmonics you give, it sounds less metallic. So that's all good. Yeah, you don't want to sit there and twiddle the knobs all the time. Of course not. This is a synthesizer. You've got to have low frequency oscillators and things to modify. So this is our slope circuit. So far we've seen the low pass gate, the mixer. So of course I can go between our triangle and our mix, or you can have anywhere in between. So that's the output section. We've seen our envelope section, so attack, sustain, decay, and release. And this last part of the envelope is actually goes between exponential and linear. So you know, goes on, goes off. You can have a look at the green light. If I go to exponential, we still get it. It's not just an on-off like a gate, but that's exponential. You can get really snappy. For example, if I was to put that all the way up and make that a bit longer, so you get very snappy. You can make drum beats and things like that. So let's go back to what it was. And we now have a slope section. Now this is like the jack of all trades. It really is just creating a slope. You can go up and then down. There's no sustain, there's no hold. We control the rise time and we control the fall time. Now we also can put in a time CV, and that effectively just slows up and speeds down. So, and also here we have the difference between exponential to logarithmic, and that line shows you linear. So, and you can also loop this. Press the button and we'll make it a bit faster. So you can see we can go up and down. I can make the attack very short, and you see the green light immediately flashes on and goes away. So we have that slope out. We also have an end of cycle. End of cycle is what happens after the rise has finished. But just for fun, just to show. So now the other thing is that's by default routed into the wave shaper. So just for now, what we'll do, take him out. So we're just going to get the nice smooth triangle wave, but I will take the output of the slope because it's easiest to demonstrate like this, and I'm going to, I don't even show the math section. I'll take our voltage and add a percentage, add a part of the slope. So that's probably easy to see. Now I can change the attack, so instead of being instant, it now goes up and down. Now I can change from exponential. So what exponential is it starts off slowly and then goes up fast. So we'll go, okay, make it much slower to hear. So hear how it rises slowly and then all of a sudden it goes up, and we can do exactly the opposite. Logarithmic starts fast and then finishes slow. Have to make it a bit faster, otherwise you'll be here forever. So you hear that one, it starts off going up fast and then slows down at the top. Now that's the slope circuit. Now if you don't cycle it, there's a trigger. So of course you can trigger it on anything you want. You can trigger it off the cycle finishing here. You can use a stacking cable and go from the gate, but it gives you options. Now I said in the beginning that we're going to ignore this, except for one thing. These are programmable. Now you have to press various weird combinations. You can see the combinations on the bottom of the device. There's actually a legend. But what I've got is I've got this set up as a triangle LFO. So you can see the rate, again, you can set the rate with that. What we can do is we can do exactly the same thing. Instead of now cycling it from our slope, we can cycle from our LFO. So that's the math section is basically this voltage plus that times this, and that's an attenuverter, so you can also go negative. But if you want a vibrato, you can press it fast. Vibrato. Okay. Yeah, that's probably all I need to go through on the no coast. Let's go to the Strega. Okay, how do you describe the Strega? I think Makenoise called it an alchemical experiment, and you know what? That's probably pretty close. So, breaking it down, we have, I call it really 3 sections. There is the first section here is a preamp with an envelope follower and an output for randomness. And the randomness is calculated from the rest of the device, how it's all set up. You then have an oscillator, and then the rest of the device is concentrating on the time filter. It's an interesting take on a delay. So they're using, well, I think they described it as a karaoke delay, like basically a standard delay chip, but they've gone past what you'd normally call the safe limits. So you can do some just crazy stuff. So let's just show. Now, the other thing is, things are a bit different. So of course, most synthesizers have oscillator, VCA and a filter, maybe not in that order, and maybe a delay processor. Not really with Strega. And Strega doesn't even have a VCA as such. They have the activation. This is actually a ring modulator, because a ring modulator, when used in DC, is quite happily able to do just the same thing as a VCA. So if I turn this up, now the pre-routing takes this into the output section. So if I turn it up, you won't hear anything, because of course what I haven't done is change the output. So let's do this. Okay, so if I turn this up, you hear a note. Now, pretty ordinary note. You've got a wave shaper, because again, being West Coast, wave shaper, you have activation. Each of these have attenuverters on them, so I can override the default sync. Nothing's coming in, so nothing happens, but I can put a signal in, and I can use this as a ring modulator to get some really interesting effects, or I can just use it as a like a normal VCA. Then you have randomness, so I can now twist this, and it doesn't do what I thought it should. Yeah. And the reason was because I actually had it already up to as loud as it can. But let's make this a bit louder. So you can see the activation has now got randomness. So it goes on and off in a random way. And you may not think there's much use for it, but it, when done subtly, it can actually just lend an interest to the sound. Anyway, so just for fun, let's do this. So remember the patch we did in the beginning with the no control, or the no coast, sorry. We used the math section to generate a voltage to open up the dynamics. Well, we are going to use the math section to open up the ring modulator. So, okay, now, as it's a ring modulator, if I turn it the other way, negative, exactly the same. You might, what? Well, I don't understand. All the ring modulator does is it multiplies the signal together. So if you multiply by a negative number, all that's going to happen is it'll be exactly the same signal, just inverted. So to us it sounds exactly the same. If you were to look at it on a scope, you'd actually see instead of going up, down, it actually goes down, up. But that's that's neither here nor there. But I can now see I can go negative or positive, see, and all that happens is it will activate it. Now, while we're here, we've got to do this. So let's take the output from our oscillator here, and we'll take the, I'll use a smaller cable just because it's neater. I'm going to control the activation with the triangle wave. And there is a ring modulator. That's everyone knows and loves. Okay, enough goodness. So we don't have any of the really normal things. We have, instead of a VCA, we've got a ring modulator, which does the same sort of job. We have a wave folder, so it goes from our triangle wave to an almost sawtooth to a pulse, like a sub-pulse. Quite actually a nice sound when you get an oscillator or VCO, or an LFO modifying it. And of course the wave shape also has its own input with an attenuverter. Okay, so, oh, and actually while we're here we'll also mention the first section, which is our preamp. Now, this is the way that you can chain modules together easily. I can take the output from this, put it into here, and feed it through the filter. So let's do that. So if I was to take the output, now we've got headphones or modular level. If you use modular level, it's really just an input. You can turn the volume all the way to the lowest. That's the black one up there, and that accepts modular input. This is how much the modular input gets fed into the filter. So at the moment, I can turn it up, oh, nothing happens. This thing's not making a sound. So what's our trick? Well, dynamic. So we can now make some sound. And feeding it through. Okay, that's really exciting, I hear you say, but it's the way to easily get signals from one side to another. You can, of course, directly do things, as we did with the weird ring modulator. We can plug things straight in, but this is an easy way. It's like another mixer. So it mixes the oscillator with this. So, okay, now filter, time filter, and delay. So Strega has a standard delay. So you put a signal in and it delays it and plays it. It then feeds itself back through a filter with absorb, which I'm still not 100% sure what it does, but I know one effect you can do with it. And it has a decay. That's how strong the feedback is. So in normal decay, well, in a normal sort of delay circuit, that's your time. That filter is, it controls the sound. So you can go from an old tape type sound to a modern digital filter. This is the feedback level. So okay, let's do something. Here's our wet and dry sound. So at the moment, we have a standard sound. Now go half wet, half dry. Doesn't really sound like much. I mean, it just sounds normal. What happens if we change the pitch? So there is a delay. Now you can control, if this can go to self-oscillation, so it gets to the point where pretty much stays forever. We can also change, for example, if we turn the filter down, you can hear that it actually cuts back and only gives you the low frequencies, or we can go all the way. Now, from what I can see, absorb does the same sort of thing as the filter, but without any filtering. So, if I crank absorb right up, hear how there's even a bit of clipping, and I think absorb actually amplifies. One reason I think that is because if I now bring in the filter, we get what sounds to my ear like a resonance. Listen. It's probably hard to hear, maybe with a different, but let's just do, see if we, it's a bit of a wave-shaped. We put our absorb in. Now, I don't know if you heard that. Sounds a bit like resonance. Anyway, if you want just a nice, if you just want to use the Strega time filter as what I call a standard, nice sounding delay, which in some ways is a bit of a waste, but just for fun, I tend to go for 12 o'clock, absorb down and decay down, and that's at about 12. So I can now and you can obviously control wet and dry, so little tiny bit of decay, or go for it, or only. So those are the components. What can you do? Well, again, I did sort of half promise at the beginning, Krell patch. So we can do some interesting stuff. One thing we haven't shown yet, so I'll leave this plug in so we can hear the output, and I'll even leave the dynamics just for now. What we can do is we can use frequency modulation, which was always the promise of the No Coast, but it was hard to do. So how can we actually get that? I'm going to take the triangle wave from Strega, put it into the linear. So, okay, so it's triangle on, put it back to here, triangle on triangle. I can turn up the frequency modulation, and we get that frequency modulation sound. So now I can change the modulation. Actually, we'll turn off the, so and again, I mean, wherever you want to do the standard frequency modulation, you can if I increase the so I can hear the oscillator here. So there's like a fifth. I can obviously tune that. Okay, there's a sort of a reasonably pleasing sound. So now instead of having this, what we're going to do is, of course, control our gate. So, but I'm going to make this into a belly chimey thing, so I have no sustain. I'm going to exponential, instant attack, and I'll leave it. Well, that's good, except we don't have any pitch. This is where we can bring in a stacking cable. It's not really stacking, but it's a dual cable. I've got my scale still turned on, so I can do 1 volt per octave there. I can have 1 volt per octave here, and because they're both 1 volt per octave and they track pretty much the same, you are going to continue, like you'll be consistent in your frequency modulation. Now, if that's too long, change the delay a bit. Maybe turn this up a bit. Okay. I heard you say a bit of delay. Let's put it up to 12. So maybe too much. You can also, but as this is the time, if that's too long a delay, you get more of a reverb sound. So you can mess around with the filter. As I said, just for messing around here, I just like doing it there. Just put a little tiny bit. So and that's a really simple patch, but we've now made use of some quite complex thoughts. So we've got a frequency modulated oscillator, linear frequency modulation, unlike the vast majority of subtractive synths which actually only have exponential, and so it doesn't sound quite the same. These both track 1 volt per octave, so it stays in tune, at least definitely over this octave. And then we've got an exponential snappy low pass gate, giving us that chime type sound, passing it through Strega's filter, and we're in normal mode in the filter. So this is more the delay filter. So this sounds more like a tape delay. So it gives that quite pleasant thing. So I know most people have heard some of the YouTube videos or seen them with Strega just screaming. You can make it sound really pretty. Anyway, so let's keep going. So we actually want to keep this because we like that sound. So we've got a frequency modulated sound. Let's make that the basis of our Krell patch. So, okay, we'll start off. Normally a Krell patch wouldn't use any keyboards. We're actually going to do something a bit later, but we can now, in fact, I'll leave this in just so we can see how it works. I can take our voltage and I can now put it in to the random circuit. Right, so every time there's a new clock, we change. So let's make that a bit more programmable. So it doesn't really matter here what we do. So we're going to have a cycling oscillator. Oh, and by the way, I did forget, the Strega also has, it's like an LFO crossed with an envelope. So you can trigger or cycle in the same way as the slope. So you can actually, the Strega can be a full synth voice. But anyway, so we've now got an oscillator. We're going to take the output of that and put it into the tempo. So if you have a look, you can now see the LEDs now flickering. So okay, that's all good and well, but we're now not triggering at the correct time. So what we really need to do is use a stacking cable again. So our stacking cable is going to take our clock, and it's also going to feed our trigger. Now, interestingly enough, that doesn't seem to work. That's because we've actually got an analog voltage coming out. That's the triangle wave. What we can do is go from the end of cycle. So that gets triggered every time the attack finishes. Excellent. So we've now got a random voltage giving a random pitch, which is frequency modulated, going through our filter. So it sounds all cool, but it's very regular in time. So we need another source of randomness. Normally the Krell patch would use the same, which would mean high pitches are quick, low pitches are slow. We want two sources. Well, Strega is all about random. So if we go into the time and plug it into the source of randomness, okay, that seems that, you know, sometimes it's a bit fast and a bit slow. If only we could slow it down. Well, of course, we've got a maths section. So take our maths, plug it into the maths side. So we're going to now attenuate. We can play with the filter. So we have a different form of Krell patch. I mean, it's the same idea, but just sort of showcasing some of the things you can do. So we have two sources of randomness. And by the way, there's another Krell patch where we actually use this envelope as a slew generator. So you can actually slew between notes, which can sound quite nice. Maybe that's for another video. We also haven't used our activation. Now, just to show, that isn't 1 volt per octave. That'd be awesome if it was, but it's not. But what we can do is we can actually cycle it. So at the moment it's a cycling LFO, so see if I go faster you can see the LED flash. But I can control the time in the same way, and this time I'm going to use the no control, the bottom row. Now what am I going to do with that? Well, we're not doing any wave shaping, so our sound is pretty similar. I'm going to put something in here, and you know what I'm going to put in? The output of our cyclable oscillator. So, can't really hear it at the moment until you turn up. And you can control the shape, so more like a sawtooth. So we can now control it with these knobs. So I'm just going to do some random placing and start that sequence. I hope that's loud enough. Let's see if I can increase the volume of the speakers. So we've got a Krell patch. It's actually got 2 notes because we're using no coast or no control to feed the activation loopable oscillator, turning it into an oscillator. Now, again, we could say, well, that's all good, but they're not moving together. I mean, I could always just take the output here and also feed it to the clock in. That's just changing the filter. Remember the non-existent filter in the no coast? So you can tell the difference. Bit of filtering. At that point there, we actually use both the VCA and VCF. So I normally treat things, I normally keep them at roughly the line, but yeah. So I'll just turn him off because he doesn't need. So that is, and again, we can easily tweak this, make it sound lots nicer and everything, but that's a form of Krell patch using the Dark Easel, and hopefully it's giving you a bit of an idea of what all the sections do, and just shows you that the total is much greater than the sum of all the parts. I might make another video. I mean, this thing can make the sweetest of sounds, or it can just, again, make the most crazy noises. We really haven't touched, well, we haven't really gone through the Strega time filter at all. It just has so much scope, and all of the activations, all of the random bits that actually change. I mean, we can, maybe we'll just quickly. Just turn him down. Actually, leave him up there. Oops, that's that volume, isn't it? So we can actually change the activation, like the time circuit with this. So we have randomness. So for example, I can now it may be hard to hear, but instead of that really nice clean filter, you may be able to hear there's a bit of grunge in the background. That's because we're turning up and down the time, and with delays, be it a bucket brigade or just a digital filter, a digital delay, as you go up and down, it changes the frequency. So we're randomly changing the time. You can hear that it's just got a bit of grit in the background. If I turn it off, it goes back to that really crystalline, delay. And again, we can play with the FM and get different sort of chime effects. But yeah, so this is the Dark Easel through massively expensive $15 USB speakers. So you don't need a huge sound system. I mean, if you can imagine this through a expensive sound system, it'd be awesome. But yeah, this is just a quick introduction, and the reason I got it, and the reason I love it. It's just a stunning device. So if you want to see anything else, if you want any other things explained, or if you want me to show certain types of patch on the Dark Easel, drop me a line in the comments, and yeah, we'll hopefully see you in a new video much more regularly than the last gap. Okay, thanks for watching, and we'll catch you next time. Bye.